Hello everyone, this is Hitesh Shah from Rakuten Catalog Platform team, and today I'm here to talk about our journey from Cassandra to ScyllaDB. What are some of the challenges we were running into Cassandra and why we opted for ScyllaDB? So, brief introduction about me. I have been with Rakuten for almost 5+ years now by now, and I have seen as well as participated into the growth of the catalog platform here at Rakuten. At heart, I'm truly a passionate engineer. I have predominantly worked with various technology firms, and I pride myself into focused on development as well as operational aspects of the product development. Uh, uh, Pushing the envelope of the technology is what I love on a day-to-day basis, and that's what I strive for doing it at Rakuten as well. My current interests include distributed systems as well as dynamically scalable platforms. So quick overview in terms of the agenda. I'm going to start with overview of RCP, what kind of use cases we are supporting and what kind of services we are providing. Then I will have a quick overview, very high level overview of the pipeline architecture we are using, as well as some of the transaction volumes we are supporting on our platform. Then we will dive deeper into our experience as well as challenges with Cassandra and why we started looking into Scylla and what value added Scylla was providing. At the end, I will spend some time to share some of the KPI improvements we have seen after we migrated to ScyllaDB. So as the name implies, we are a product catalog platform team. So if you are into online e-commerce shopping and if you are into cashback, and let's say you go to Rakuten.com and you're searching for, you're looking for a new iPhone. So you search for iPhone on Rakuten.com and you will get the search results saying that, iPhone from JCPenney at certain price, iPhone from Target at certain price, iPhone from Walmart at certain price. So those search results are powered by this platform. And we are a truly global team. We are responsible for a lot of the global assets across Rakuten worldwide. So on the right, if you go to, let's say, Rakuten Japan, rakuten.co.jp, and let's say again you're looking for an iPhone and you search for iPhone and you get the search results saying that iPhone from this merchant in the marketplace at this price and this deal, as well as iPhone from some other merchant in the same marketplace at a different price. So again, those search results are powered by this platform. And the way in which we do that is that we have this offline ingestion platform to power these results and this product catalog. We source the catalog data from multiple sources, and once it is downloaded into the system, there is a core data processing engine which will kind of like normalize the product data, validate the data, and transform the data. And at the end of the pipeline, the catalog data will get stored into the ScyllaDB. So ScyllaDB is at the core of this platform to power the platform as well as support the platform. And in between the platform teams, there is a queuing based, I will say queuing based integration, different various microservices. So for example, the machine learning enrichment will happen via this pipeline, and once the enrichment happens, the data will get stored into ScyllaDB, and the catalog data will be sent out in the bottom to our partners as well as internal customers. So in terms of the core technology stack, pretty much I will say Spark, Scylla, Redis, Kafka. We are also on Google Cloud Platform, so pretty much pops up Dataproc as well as Dataflow. In terms of the programming model, we are kind of like using is pretty much batching as well as micro batching, and some streaming also we have. So in terms of the data processing volume we are handling right now, the total catalog size is close to 700 million plus, and pretty soon approaching 1 billion plus items or listings in the catalog. The number of daily items we are processing is close to 250 million plus, and again, given the growth is continue to go up. So all being said and done, after all these optimizations, and by the time the transaction reaches to ScyllaDB, in terms of the read QPS we see at Scylla level is close to 10K to 15K QPS per node, as well as the write QPS is in the range of anywhere from 3K to 5K transactions per node. So here is a quick Grafana chart, a recent chart of some of the Scylla nodes, basically what we are monitoring internally. So you can pretty much see that on the left hand side is the read QPS, pretty much in the 10K plus minus range, as well as on the right bottom right is the write QPS, and I mean you can pretty much see that servers are super busy basically. All right, so let's dive deeper into some of the issues we have seen with Cassandra. So one of the main reason was the inconsistent performance, or what I like to call the volatile latencies. So let's say if I have a select query which is returning, returning results back in 70 millisecond, that exact same query will take, let's say, 120 millisecond at a different time of the day, or could even take 140 or 180 millisecond or a different day. So it was very hard to predict the performance of the system, as well as it was very hard to commit to the SLAs to our partners. Cassandra being a Java-based system, it also had its own baggage of JVM issues, and definitely we had our own fair share of out-of-memory issues as well. We also used to run into a lot of the long GC pauses, which will come, which will freeze the node right in the middle of all this activity, and kind of result into server-side connection timeout for many of our clients. One of the major issues which was very prevalent with us was a single slow node can actually bring down the whole Cassandra cluster, and this is very common with a lot of the distributed systems, but much more prevalent in Cassandra. And the reason for this is because a lot of these distributed systems has these concepts of sharding and the leaders and replica. So there is a lot of peer-to-peer network chatter going on behind the scene. So for some reason, if one of the node is performing slower, then it will not be able to process all the requests it is receiving, as well as it will kind of not be able to propagate those requests. So eventually, basically, it will start slowing down the other nodes in the cluster, and eventually the whole cluster will come down. Some of the other issues were definitely Cassandra requires a lot of manual operations, a lot of babysitting. We pretty much had to have a full-time DBA to make sure that we are on top of all the repairs, as well as all the jobs are running fine. So having said all these things, we were able to scale up the Cassandra. Cassandra was definitely naturally horizontally scalable, but what we realized that it was coming at a stiff cost. So just around approximately 2 years around the same time, kind of like we started internally realizing that Cassandra was not the answer to our next stage of growth of the catalog platform. So enter Scylla, that's where we bumped into ScyllaDB, and we did a basically initial POC of couple of months to test out our primary use cases. And all behold, basically we kind of like saw that out of the box there was 5 times to 6 times performance improvement in ScyllaDB. So we kind of like went ahead with the migration. So again, so let me just quickly run through what are some of the other benefits we have seen with the Scylla. So again, as I said, 5 to 6x performance improvement, much more improved total cost of ownerships, because we went down from 21 to or 24 Cassandra nodes to 6 nodes in Scylla, as well as much better ROI, because any code which is running in C++ versus Java on the same set of hardware will definitely give you a better ROI. And one of the biggest, I would say, peace of mind was that we started having these consistent latencies. So queries were performing pretty much in a predictable fashion, and we started committing to SLS to our internal partners as well as customers. One other reason we're kind of like attracted to Scylla was the underlying C star framework. And the much better improved parallelism, where basically the shared nothing architecture, or shard per core approach, which reduces the kernel level contentions substantially and improves your performance. And again, last but not least, one of the biggest advantage was it was just a drop-in replacement. So we could basically spin out a new Scylla cluster, migrate our data, and start pointing our application to Scylla, and boom, we were running in production. Why Scylla Enterprise? So just quickly run through some of the benefits of the enterprise version, at least what we saw. So once we started doing POC, we kind of like started realizing, because of the complexity of the technology as well, that enterprise version will make sense. And one of the main reason is that with the enterprise version, it comes with the private Slack channel for the customer support, and with their own SLS, and we have benefited tremendously from this private Slack channel and with the immediate turnaround of the issues. The one other advantage was that for the enterprise customer, the Scylla comes with a custom shard aware driver, which improves the utilization of the node of the cluster substantially. And the incremental compaction strategy, or ICS, is one other benefit which actually really fitted really well with our use case, where we have a schema or a table which is generating a lot of tombstones, as well as it is heavily transaction oriented, lots of reads and write. So that's where ICS made a lot of sense for us to basically balance out the disk space usage as well as the CPU usage. And again, some other key things are workload prioritization, which we are evaluating to integrate into our use cases, as well as Scylla Manager, which is one of the biggest benefit because we no longer had to babysit the cluster. Okay. So quick diagram on the shard aware driver. So this is taken the snapshot from our internal POC. So on the top left is the datasex driver, running against Scylla. So you can see how the director is serving the request, and on the bottom right is basically the Scylla custom shard aware driver, and you can see that the parallelism has improved substantially, and you are getting much better utilization of the nodes, as well as the director is busy basically. And we actually internally saw at least close to 15% to 20% improvements in our query because of the driver. So last but not least, let me quickly share some of the KPI improvements we have seen. So our average feed ingestion times improved by 30 to 35%, which resulted into improved SLS for our internal partners and customers, and improved customer satisfaction. We also, once the feeds are processed, we also do outbound publishing of the feeds, which resulted into almost 2.5 times to 5 times improvements, which resulted into much more satisfaction for our merchants, because now they can quickly turn around the price changes as well as availability changes to the site. And one of the biggest benefit was basically the dollar savings in the hardware as well as processing costs. So as I said, we went from 21 or 24 nodes in Cassandra to 6 nodes in Scylla. So substantial dollar savings in hardware. Not only that, but just by the sheer fact that we are running in Google Cloud Platform, because Scylla is performing close to 5 times to 6 times faster, our processing times reduced, which resulted into the reduced cost for the data proc and data flow jobs. So definitely a lot of improvements over there as well. So that's pretty much what I wanted to cover. Thank you for joining my talk. You can stay in touch with me. I have my LinkedIn profile over here. Also, I have my Rakuten email address. Feel free to get in touch with me or shoot me any questions, and enjoy the rest of your conference. Thank you.